Symmetry. Now, this is very useful when it comes to drawing pictures of our graphs. If we know something about the symmetry, and there's two very special types of functions. We have our odd functions, and the definition of the odd function is this. Function negative x is equal to the negative of function x. It basically has point symmetry about the origin. So point symmetry is when you rotate it 180 degrees and you get the same picture. That comes back to our transformation that we saw where function x equals negative function negative x was a rotation. Okay, so spin it 180 degrees, the picture will look the same. So visually, very easy to tell. For instance, I can tell the cubic is an odd function if I spin that 180 degrees. The parabola, however, no. Hyperbola, yes. What about the circle? Yes or no? Spin it 180 degrees, it looks the same. So is that a yes or a no? Come on, be brave. Hands for yes. Hands for no. Hands for I'm not brave enough. The correct answer is no. It is not an odd function because, of course, it's not a function. There you go. Right, so some examples of odd functions. You got y equals x cubed would be an odd function. We just saw that visually. The hyperbola, we just saw that visually. 1 on x. In fact, x to the power of 7 minus x to the power of 5, that would be an odd function, as would minus 3x to the power of 9 plus 2x to the power of 7. In fact, if you've got a polynomial, or not a polynomial, y equals 1 on x is not a polynomial, but basically if you're looking at the powers and all the powers are odd, it's going to be an odd function. But of course that's not good enough for a proof. So let's go and prove x cubed plus x to the 7 is an odd function. In order to prove it, we have to show it satisfies our condition. So function x, that's what we're investigating, x cubed plus x to the power of 7. Let's now investigate what function negative x is. Substitute in negative x. Well, if I cube a negative, I'll get a negative. If I raise a negative to the power of 7, I'll get a negative. I could factorise that to be negative function x. It satisfies the criteria. So yes, that is an odd function. Well, then there are even functions. Criteria for an even function. Function negative x is equal to function x. And back to our transformations again, that was a reflection in the y-axis. So we end up with something like line symmetry. So something with line symmetry about the y-axis. In other words, y-axis, axis symmetry. Again, looking at pictures visually, we can see, yes, the parabola has line symmetry. So yes, that is an even function. Cubic, no. Hyperbola, no. What about the circle? Yeah, no one's going to fall for it twice, are they? Okay, so some examples. Y equals x squared plus 4. If I shifted the whole thing up 4, that would still have symmetry. Minus 3x6, 2x7, minus 27x squared. That would be an even function. If all the powers are even, then for the sake of this we're saying 0 is an even number. Well, it satisfies all the criteria for an even number, which basically means a constant is okay, because that's like saying something x to the power of 0. In fact, let's prove the x squared plus 4 is an even function. Right. Function x squared plus 4. Substitute in negative x. Well, if I square a negative number, I get a positive number. So we get x squared plus 4, which is function x. But yep, satisfies my criteria. That is an even function. All right, quick one there to start off with.